Okay.
Otherwise,
I was going to ask it.
Few seconds still.
Yeah. Everyone's heard of
Nobody really keeps a shit like bombs. I mean, you know.
Yeah, most everyone does. Everyone anyways. Welcome, everybody. This is the presentation on the Harlan County Mini Roundabout and Bridging Kentucky Project Collaboration. This will be presented by Jennifer Hardwick, Darrell Smith, and Mike Vaughn. Jennifer chose a career in engineering following footsteps of her father and grandfather. She attended UK and graduated in 2001 with a degree in engineering and a minor in music performance that she hasn't been able to use in her career. She spent the past 6 years working on HSIP projects with Integrated Engineering and Prime Aid. Darrell Smith is an experienced project manager. He has over 16 years of experience working as a consultant to state, local, and private organizations. He graduated from West Virginia University Institute of Technology. Has a lot of experience in a lot of different types of modeling programs. Mike Vaughn is a transportation engineering specialist for KYTC within the Division of Traffic Operations at Central Office. In his current role, Mr. Vaughn is one of 3 engineers who administers KYTC's HSIP program. He is also one of KYTC's representative on AASHTO Committee on Safety. Mr. Vaughn has worked with the HSIP program since April 2014. He lives in Frankfurt with his wife, Emily, and 2 boys, Mason and Aaron. In June 2016, Mr. Vaughn checked off a major bucket list item when he played in event number 33 at the World Series of Poker.
And I'll confirm for those curious, I did not win any money. So it was the most fun I had losing $1,500 though. And that sounds like a lot, but it's really not the world of poker. All right, so today's presentation is going to be about the successful collaboration of a mini roundabout project and a Bridging Kentucky project. Let's see, let's go over real quick some of the stuff we're going to cover. I'm going to spend a few minutes of the presentation talking about what made this a unique collaboration. Jennifer Hardwick is going to then give an overview of the mini roundabout project. And Darrell Smith, he's joining us virtually, but he's going to talk about an overview of the bridge replacement project and then talk about some of the unique collaboration efforts that went on to pull off this project or this bundling of projects. So first, let's kind of get oriented where these 2 projects are located. As the title suggests, they are in Harlan County. That's the far southeast corner of the state. They're in the community of Harlan. The city of Harlan is the county seat of Harlan County. The mini roundabout project is at the intersection of Kentucky 38 and Kentucky 72. And then the bridge replacement is at the intersection. It's where Kentucky 72 goes over Clover Fork. If you're wondering why there's only 1 red dot, it's because both projects are practically on top of each other. Here's kind of an aerial, shows what I mean. The center of the bridge is about 120 feet north of the center of the intersection. And then here's a street view that shows kind of a profile view of the bridge. You can see the intersection toward the right. The southern end of the bridge to that nearest crosswalk is about 20 feet. So again, these projects are pretty close to being on top of each other. Here's a snapshot of kind of the main plan sheet. You'll notice the bridge replacement, the proposed structure is actually a reinforced concrete box culvert. It's under the north leg of the intersection. It's in the transition zone where that north leg widens out to make room for a splitter island as southbound traffic approaches the roundabout. Now, you might be thinking, well, hey, he just said he was going to cover what made it unique, and he just keeps telling us about where stuff is. Well, the location of these projects is what makes the collaboration effort so unique. You know, 2 consulting firms coordinating and collaborating. That happens somewhat regular, but in those cases, it's generally two projects that touch each other at basically a single cross section or a single point. And so most of the collaboration is just making sure, hey, does your road line up with my section? You know, it's just a little bit of coordination at a single point. This one was just totally different. About a third of the mini roundabout footprint was over top of about half of the Bridging Kentucky project's footprint, with almost all of the roundabout footprint being over the actual structure itself. And so that really grayed the lines between, well, what part of this project is in your plan set and what part of the project's in my plan set, and where do we draw the line to, hey, you calculate your bid items on this side and I calculate my bid items on my side. We didn't really have that nice neat line, so we just sort of invented one. We ended up flipping the script, so to speak, and divided it vertically. So subgrade became our dividing line. Most all of the bid items below subgrade went into the Bridging Kentucky project, and most all of the bid items above the subgrade went into the mini roundabout project. And, kind of setting that as our dividing line really helped to not necessarily simplify, because it's still pretty complex, but it just made it a little, the grayness a little clearer, more clear on who was going to cover what. Jennifer's going to be coming up here in just a sec to cover the mini roundabout overview. Before she does, I just want to take a second to give major kudos to both AECOM and the Prime AE teams. Like I said, this is a pretty complex, unique project that they had to work together on in a pretty tight timeline too. While working through a lot of right-of-way utility stuff, and they really pulled it off and done a really good job. So just want to give major kudos to those two teams.
And I want to start by saying thank you to Mike and to all the HSIP folks and all the District 11 folks and the AECOM folks. Everyone's input and involvement in this project and all the collaboration that we did, that's really what helped make this a successful project. So I'm going to start by talking a little bit more in depth about the existing conditions at our intersection. 72 here, this is the north-south street, and it parallels US 421. And you can kind of see 421 on the left side of the larger picture there. So the existing intersection is two-way stop control. The vehicles on Kentucky 72 have the stop, and there are currently flashing beacons to warn motorists to the intersection. We do have fairly limited right-of-way, especially on the southeast corner. That parcel is owned by the Harlan Housing Authority, and the right-of-way on the left side of their parcel goes up pretty much right behind the sidewalk. So we didn't have a whole lot of room to work. And then we also had numerous utilities in the area, both overhead and underground. We had sanitary sewer, water lines, electric, telecommunications, storm sewer. So there's a lot going on at this intersection. And then to complicate matters even further, as Mike mentioned, we have the bridge on the north leg of the intersection about 20 feet behind the crosswalk. So we were assigned this as an HSIP project, and one of the first things that we do when we have an HSIP assignment is to look at 5 years of crash data and just analyze different patterns to kind of see what's going on with the crashes. And during this time period, there were 33 crashes that occurred at this intersection. 1/3 of them resulted in injury, and 73% of the crashes that occurred at this intersection were angle crashes. And of these angle crashes, most of them were either right angle crashes or left turn related crashes. And then there was also one pedestrian collision that resulted in injury. So based on this crash analysis, we were tasked at looking at the feasibility of converting this intersection to a mini roundabout. A mini roundabout is overall very similar to your conventional roundabout, it's just a little bit smaller. The inscribed diameter for a single lane urban roundabout is generally between 100 and 130 feet. If you have a rural single lane roundabout, you're generally looking at 115 to 130 feet. By contrast, for a mini roundabout, your inscribed diameter is generally going to be between 45 and 80 feet, maxing out at about 90 feet. because any bigger than that, you're getting into conventional roundabout territory. And to accommodate large vehicles of these smaller diameters, the central island and the splitter islands are either mountable or flush. And this encourages the passenger vehicles to still use the circulatory roadway, but allows for the larger trucks to make the turning movements with these smaller diameters by running over the islands. And you can also provide truck aprons on the outside corners of the intersection. And again, this is just to facilitate the right turns with the heavy vehicles. And many roundabouts have many benefits. Three I'm going to cover on the next handful of slides are safety, efficiency, and cost. As far as safety performance benefits, the big thing is conflict point related. I'm sure most of you have seen these conflict point diagrams. With a 4-leg intersection, you have 32 conflict points. And a lot of these are your crossing conflicts. And these are your left turn crashes or your right angle crashes that tend to be higher severity. By contrast, for a roundabout, you have only 8 conflict points. And these are your merging and your diverging conflict points that don't tend to result in as many injuries. Pedestrian safety is another benefit of many roundabouts. Talking about conflict points, a 4-leg intersection has 24 conflict points for pedestrians. A mini roundabout has only 8. And if you use the mountable splitter islands, you can also provide pedestrian refuge areas. And in those cases, pedestrians are only worried about crossing one direction of traffic at a time, which can make things easier for pedestrians and reduce these types of crashes. And then finally, traffic calming. And some of this is just due to the smaller nature of these roundabouts. You do have to slow down to navigate the smaller diameters. But this also ties back into pedestrian safety. And I'm going to throw some numbers at you here. For a collision between a vehicle and a pedestrian, if the vehicle is going 23 miles per hour, the average risk of death for the pedestrian is 10%. But if the vehicle is going 32 miles an hour, the average risk of death goes up to 25%. And of course, death isn't the only thing that you want to worry about if you get hit by a car. You can look at serious injuries as well. And so if vehicle speeds increase from 23 miles an hour to 32 miles an hour, the risk of severe injury to the pedestrian goes up from 25% to 50%. So slowing traffic down by use of these splitter islands or by lane narrowing, this can help with not only the severity of the vehicular crashes, but also the pedestrian crashes as well. There are also some efficiency benefits to roundabouts. The mini roundabouts support a higher capacity than an always stop control. And the capacity is only slightly less than a conventional roundabout. So you're looking at about 15 to 20,000 vehicles. And many roundabouts can address minor street congestion and major street left turns, and they do this by providing more favorable treatment to the left turn and minor street approaches because they don't prioritize the major street over the minor street. And because of this, you can potentially reduce the overall intersection delay, not only when compared to, say, an always stop control, but also potentially two-way stop control as well. And then cost benefits. A lot of this is just due to the size. If you can use more or less the existing footprint of the intersection because these are smaller, you might not have to buy as much right away. You might not have to relocate as many utilities. And these things can both add cost and time to your project. And then finally, just because you're not building as much, the overall construction costs can be lower as well. These are just some guidelines for where you might look at applying a mini roundabout. Generally, ideally, we'd like to have lower speeds on the approaches. They are most effective when the approaching roadways have a posted speed limit of 30 miles an hour or less. Also, when the approaches are 2-lane roads, and that's just because these are small single-lane roundabouts, there's not the room to just tie in multiple lanes of traffic. And then as far as volumes, you want your total volumes ideally to be less than 1,600 vehicles per hour, and you'd like to have your minor street volume be greater than 10% of the total. When we were assigned this project, the first step was to collect traffic data and do some traffic analysis. So we have mile vision cameras. We took AM and PM counts for 4-hour periods both times. And we were counting passenger vehicles, heavy trucks, and also pedestrians. And then we plug these numbers into CapEx. And if any of you are not familiar with CapEx, it's a spreadsheet that's been developed by the Federal Highway Administration. And it gives you just kind of a high level or planning level overview of how different configurations of innovative intersections might potentially function before you go all the way into a detailed microsimulation. But when we plugged our numbers into CapEx, everything still looked pretty good. So we did go ahead with the full-on microsimulation. And this is just an example of some of the information that we compiled and presented to the project team. And I'm not going to go into a lot of detail, but we looked at 6 different scenarios. We looked at a no build, a mini roundabout, and a 4-way stop scenario with existing volumes. And then we looked at each of these with a 20% growth. And we looked at the level of service for each leg of the intersection, and then also the overall intersection delay and level of service. And one thing that I want to point out here is that this is a no build scenario, so 2-way stop control with the 20% growth. And you can see that the overall intersection delay is 87 seconds. But when you look at 20% growth with the mini roundabout, the overall intersection delay is only 67 seconds, which is actually performing better than the 2-way stop control. And this is just because as the volumes go up, with the 2-way stop control, it gets more and more difficult for vehicles from Kentucky 72 to enter the intersection. So when you have a mini roundabout where preference isn't given to any one movement, that can bring down the overall intersection delay. And this is just a quick clip from our VISM microsimulation. This is the PM peak with the future volumes, obviously with the mini roundabout layout. And you can see that we did account for the traffic signal at the US 421 intersection just down the way. And overall, you can just kind of see that the vehicles are traversing the mini roundabout. We don't have significant delays or queues. And so this is something that we did as part of step 2, presenting these results to the project team. Step 3, when the traffic results look pretty good, we had to think about the final design. The first thing we had to do was set the inscribed diameter. The existing intersection is 65 feet measured diagonally, but we wanted to go a little bit bigger than that just because we have a higher percentage of trucks and we wanted to make it a little bit easier for them to get through the mini roundabout. So we ended up going with a 90-foot inscribed diameter, which is pretty much the max for your mini roundabout. And then we performed some truck turning movements and we used auto turn, looking at a WV67. And these diagrams down here, these are just some of the results of the turning movements. And you can see that the trucks, when they're making these turns, are utilizing the central island and the splitter island to help with these movements. And then you can see on the right side, the trucks that are turning right from 38 north onto Kentucky 72, these vehicles are crossing into the opposing lane. And at the time that we did these, we assumed we were constrained by the existing bridge. So we figured that while this wasn't an ideal scenario, we didn't think there was anything we could do about it. And this is the existing lane width. The trucks are already making these movements. So we were just going to go ahead with it. And so we had all our approaches and our diameter set, and we added the islands and tied in the sidewalks. And this is what our final layout looks like. You can see that we have the splitter islands on all 4 approaches, just to give a little bit better delineation. We have the crosswalks in the splitter islands. We have the 90-foot inscribed diameter. We have shifted the entire intersection up to the north just a little bit, and we did that so we could try to reduce impacts to the Harlan Housing Authority property down there in the southeast corner. And then we came to step 4. And this is not a step that I would advise adding to your mini roundabout projects. But what happened was that when this project was originally assigned, the HSIP folks knew that they wanted to look at converting it to a mini roundabout. And the Bridging in Kentucky, or District 11 folks, knew that there was a Bridging Kentucky project coming, but they didn't know what the timeline was or what exactly was going to be done as part of this project. So we were working through our design, And we found out that the Bridge in Kentucky project was a lot further along than we thought. And we had kind of an oh crap moment, because then we knew that not only did we have some catching up to do, but we also had to do a lot of coordination with the Bridge in Kentucky team just to make sure that everything fit, everything worked, there wasn't any overlap, and that we could get both projects coordinated and led together. And so now I'm going to turn it over to Darrell with AECom, and he's going to tell us a little bit more about the Bridge in Kentucky project and some of the coordination that we did.
Oh, okay. Yeah, I'll do that real quick. Sorry for the delay. There he is, Darrell, my co-host. Yes. And so Darrell, you should be able to share your screen now.
All right. Can y'all see that? Hopefully you can see my screen and hear me.
Yeah, we can hear you.
Good deal.
I'm getting the screen locked up on me for a second. All right, now you're good to go.
Okay. Well, good afternoon, everybody. My name is Darrell Smith with AECom. As Mike mentioned, I'll be briefly hitting on the Bridge in Kentucky project and covering some ways that the HSIP and the Bridge in Kentucky team coordinated efforts to combine these projects. I think I rambled a little bit this morning, so I'll try to get through these slides. That way leave a little room for questions at the end. But I was one of many people working on this project, along with many other consultants. And at the end of the day, it was a project to replace the existing bridge. The bridge number was 48B95N, which had multiple substandard bridge inspections and came back with poor ratings.
Darrell, if you're sharing your screen, it's not fully came through, so you may have to start it over. I don't know.
Okay.
We still see your pretty face.
Oh, no, that's not good. That's definitely an oh crap moment then. Let me see. How about now?
Now we go.
Okay, sorry. So the first slide was just introductory anyway. So, all right. Like I said, I'll be covering this the Bridge in Kentucky portion and some of the coordination as well. As you might have heard, I went to college in West Virginia, and so I didn't really know a whole lot about Harlan other than a couple good country songs about it. And so, I did know that there was a lot of flooding events, and in particular, the 1977 event that provoked the project of Clover Fork being diverted under the hill in a tunnel system. And then in the 90s, a flood wall was constructed along US 421, which is downstream of the bridge that we were looking at. And so, definitely really cool projects there. And where Clover Fork goes underneath the hill is up here where the little blue arrow is. And something definitely, if you haven't been there to check it out, I would. That and Pikeville are just some really cool construction feats in my mind. So a little bit about the existing structure. It's a concrete arch structure that facilitates the Main Street, which is Kentucky 72, over the Clover Fork of the Cumberland River. It was built in 1945, and today it has a 2-lane curb and sidewalk section, approximately 38 feet out to out, and the overall length is about 255 feet. And early in the program, the Bridge in Kentucky program, we looked at multiple bridges, and this one was screened from the existing data and analyzed to develop a scope. The screening also developed program level cost estimates to compare a replacement alternative. this bridge originally began as a rehabilitation. But during the rehab development, the project team couldn't really load rate the existing structure accurately due to the lack of archive structure plans on this one. So for early stages, we held multiple coordination meetings, one being the rehab scope assessment. And this was a crucial variable in the determination of the repairs, not being able to fully load rate it. So the big question that we were always, kind of in the back of our heads is like, well, what kind of performance would a rehab provide on this pretty long structure? Just the large concrete arch spans likely would have been a costly rehab. And we got also some comments back from KYTC District 11, and they had suggested a demo and replacement with a culvert. So we kind of dug our heels in and looked a little bit more into that. So at the conclusion of our rehab scope assessment meeting, the project team proposed to change the scope from a rehab to a full replacement. Now that the Clover Fork was no longer flowing under the concrete arches as it did before, being diverted under the hill, some of the floodway was filled in as well as part of the north span of the bridge. So the project team moved forward with another kind of coordination assessment meeting, project site assessment, to meet with each discipline to confirm various recommendations and develop work scopes and a schedule. Like I said, there was some issues along the existing structure from that fill. There's floodway was being filled in. You can kind of see over here, there's a gaping wall, there's some utility conduits. On the northwest side of the bridge, there was an existing parking structure erected, and along Main Street, there's some development along with the tourist committee welcome center. And then, as Mike and Jennifer alluded to, Kentucky 38 intersection was just to the south of the bridge as well. So we held a lot of coordination meetings with the city and the U.S. Army Corps of Engineers, and began to analyze the existing hydraulic opening of the bridge and the storage of the remaining floodway that was left after the fill. You can kind of see when Kentucky 38 came through, a 10x6 culvert actually was constructed with that project. So we began to kind of analyze that as kind of our first steps. That was kind of our step one, was like, well, we know there's a 10x6, so let's start there and see where that lands us on some calculations. So typically the bridging projects that I'd worked on, we mainly tried to keep the scope to replace bridges in kind, but with the complexity of this structure and the size, compared to the need of the hydraulics and the storage for the floodway, the cost would have been much greater. So the scope, we came back to the table and determined to replace the structure with the reinforced concrete box culvert. So some things that we looked at when we were comparing the RCBC with the bridge, obviously, inevitably, was the savings from the cost and the ease of constructability, while still providing the design life and allowing the volume and the storage capacity. Other variables that we looked at as well included impacts as far as environmental, utilities, and right-of-way. We considered maintenance and additional volume of fill within the U.S. Army Corps of Engineers floodway that they owned. And then also, coming back with another bridge, finding a good location for the south abutment would have been pretty tight alongside the Kentucky 38 intersection to the south. There's also a gravity sanitary sewer line main, which is it's just north of the south abutment. That would have kind of been a little bit difficult to fit another abutment in there. So continuing on, our preliminary design was we start off with an 8x8 single RCBC that had about a little over 7,000 yards of embankment in the fill area. So after, again, multiple coordination meetings with the U.S. Army Corps of Engineers and I don't know how many hydraulic models that we calculated, and the Corps of Engineers did as well to do reviews. They updated their model. They kind of back checked ours and then came back and said that they wanted to require the hydraulic opening to be a minimum of 256 square feet for the adequate storage. So we ended up with getting a final configuration of a triple 10 by 10 box. So throughout the bridging program replacement project, development of the construction plans, multiple coordination efforts was needed to pull all the disciplines together to finalize the project. U.S. Army Corps of Engineers performed independent hydraulics to coordinate risk concerns with the county and city. That was done to require concurrence from the judge prior to issuing the final permit. Like I said, that the floodway and all the new embankment that was going to be going in there, we had to take into account with the grading in the existing channel. Additional hydraulic models were ran to check versus the demo and the embankment that was placed. And even though the storage was reduced, the replacement of the existing Kentucky 72 concrete arch bridge with the triple box showed minor impacts to the performance operation of the interior flood control or the IFC pump system that was adjacent to the flood wall. The placement of the fill was also relatively minor and increased the water surface elevation on the upstream side by approximately ½ a foot. Like I mentioned, there's some utilities impacted that was moved prior to letting. Furthermore, with the city and the county weighing in on the amount of fill in that floodway, they decided to replace a section of that sanitary main and encase it within the project limits. Other things that we were kind of battling against with was environmental, like I mentioned. We were waiting on some historical findings. It was deemed non-historical, so we progressed into the final plans design and development, and was getting ready to determine a letting date. And the other kind of hurdles that we jumped through were right away. And I think I mentioned earlier, I could probably talk, another 45 minutes on right away. And I know Jonathan McCracken, he was our right away lead. He could probably talk double that, just figuring out all the puzzle pieces along Kentucky 72 and the Army Corps of Engineers parcels. But it was about that time that we got a call from the HSIP team. And so we had a couple of phone calls and with all the complexities of this bridge, a lot of the other bridging program projects that we worked on, we got them out the door relatively quick. And so I think with this additional effort, coordination, it kind of allowed the time to kind of marry together that these two projects could incorporate one another. So when I first heard about, well, they're going to put a roundabout, I thought, well, shoot, are we going to have to redo our whole design and come up with something like, I think this is in South America somewhere. And even though it's pretty cool, that would have been probably a little bit more costly than what we had planned. And as Mike mentioned, since the projects were intertwined and overlapped and crisscrossing one another, we kind of met, and like he said, we kind of made up a new way of combining these and how we divided it. And so we basically looked at different construction bid items and costs and tried to split them up evenly. And as like I said, previously stated, the mini roundabout was going to take on the subgrading up, and the Bridging Kentucky team was going to take the subgrading down for the most part. So we basically split them vertically speaking. So now these projects would be let simultaneously under a single contract, which has its own advantages, helping out hopefully some bids, and I think we saw that. And then this meant each project team had a little bit more work to do. We had a lot of the designs were complete. but just developing the construction plans, had some revisions and adding, subtracting some items to split the project up in this unconventional way. And although the amount of revisions could have been a little bit more if for example, we would have left it a rehab, and then the roundabout came in and we're still just rehabbing the bridge, we probably would have had to go back to the drawing table for sure. And likewise, if we would have replaced the bridge in kind of the same size and overall location. But and when it came down to it, I think overall, both projects added value, and what I mean by that is like they were kind of the same sense of the right size, the right time, and the efficient design. Kind of both went hand in hand. And during the big collaboration effort, when we set up recurring meetings to coordinate each discipline as it related to the development and timeline of the projects. And by the end, we really acted as one large project team. And, there was many different people on these calls and that worked on these projects in the background that I'd take a long time to list everybody, but definitely big thanks to everybody involved. And it can be attributed to all the people, KYTC, D11, HSIP, Prime AE, and the rest of the Bridging Kentucky team members. The meetings ended up being more like working sessions, not just, just a meeting, just going over bullet points and dates that we needed to hit. And we really sat down and tried to solve the issues by revising and mitigating the combining of the projects. This was aided by holding these working sessions virtually as well, because it was in the middle of the pandemic. A lot of people tend to be a little bit more available during, maybe some virtual calls, and it definitely was advantageous in scheduling everything. So each project team performed their own QA/QC as well and reviews, but to go a little bit one step further, the HSIP team and the BKY team also provided cross-project reviews as another level of QA/QC, for basically reviewing each other's construction plans. And it was a good way to get a new set of eyes to look at those external project reviews that were critical in completing the final plans for the letting. So at the end, it really was a dual effort delivering the performance of both of these projects. And with that, I'll say thanks and give it back to Mike and Jennifer, and hopefully we get some questions this time. So appreciate everybody's time.
We have a few minutes there. Is anybody got any questions about this project? Got anything we can check on?
What's the current letting date?
It's been let. I'm trying to, we got award too. Yeah. We've had a lot of projects been coming in over and we had to reject awards, but was it, Darrell? I can't remember. Jennifer, was it July we played it?
Yeah, it was July. I just thought I saw that the other day. July 23rd, I think that was the letting date.
It was in the July letting. We got
Yes.
good bids.
Mm-hmm.
Got a lot of projects that are not getting good bids, but no, it's been awarded, and so I don't know exactly what the contractor's plan for starting is, but we will be closing down 72 for the demo and reconstruction of the box culvert. So I'm imagining most of the work will probably take place next year, but I don't know that for certain. I just can't remember too many projects we got going on. Any other questions? We appreciate everybody coming and joining us and learning a little bit about a unique project. Thanks.